Good morning, everyone. My name is Younes. Nice to meet you. I did a bachelor in neuroscience at McGill University, and currently I'm doing my master in physiology, where I'm building an interface machine which connects cardiac tissue with computational simulations in real time. And it forced me to learn many programming languages throughout the last year. You can ask your questions both in English and Persian. I'm pretty confident with both languages. Today, we are going to study multiple linear regression. This is a model which helps us to explain multidimensional data sets. For example, in a simple linear regression, we have one-dimensional data sets. For example, my data only composed of one dimension, and I try to only fit a line to my data set. But if my data set is composed of multiple dimensions, for example, it is a genome with thousands of genes, so it has thousands of dimensions, I need a multiple linear regression model to explain my data sets and to be able to fit a line or a plane to my data. For example, this is an example over here. And imagine I want to study the effect of a genome on whether behavior going to exist in my organism or not. Why going to be the probability of the existence of that behavior? And my genome is composed of thousands of genes, and each X here is a gene in my data set. I can rewrite this model, this formula in matrix formation. So y going to be the probability of the existence of that behavior, and X is my data set, where it has lots of entry. Each entry is a data from a genome, and each entry composed of many features. So like the features here are my genes, the genes in each genome. So in order to solve this model, first let's see this example. Here we have a two-dimensional data set, and I have to fit a plane to my data so I can study its effect on my result, which is y in here. So I have to find an ordinary least square in order to find the parameters suitable for my data set. And this formula comes from the one I showed you previously here. I'm just rewriting this using linear algebra and get this formula here. Then we have to make a Python code for our model, for our ordinary least squares. And here, usually I give some time to my students so they can go over it and face their challenges and to be able to solve it by themselves. But here I just solve it myself. Here from the explanation here, I know that I have to use this formula, which is using a NumPy package to find the answer. Then I'm just rewriting this formula here in Python code. So it's going to be X transpose times at is just for the matrix multiplication times X, and then times X transpose again times Y. And I just add this to my code so I can see my answer, and I just comment out this part, and ta-da, I have the answer right here. So these are the parameters for my model, and they are exactly look like the answer provided by the question. So we are using this function to find the answer for this data set we are given right here, and then find the mean square error. And the mean square error here is 0.9. So it's pretty accurate. And when we represent the data, you can see this plane is fitted to our data, and it's pretty close to the data set. And so the difference between each data entry is pretty small, and they are really close to the data. Thank you very much for listening to me over this 4 minutes. And thank you for giving me this opportunity to present myself.